Hello everyone, welcome to JavaLearnerss. In this video, we will explore the session scope of a bean. The Spring framework provides several bean scopes that determine the life cycle and visibility of a bean in the application context. These scopes are singleton, prototype, request, session, application, and WebSocket. The last four scopes, request, session, application, and WebSocket, are specifically designed for web applications. In this video, we will explore the session scoped bean in detail. In the Spring framework, a session scoped bean is a bean that is created once per HTTP request. It is shared across multiple HTTP requests from the same user in the same session. It remains active until the session expires or the session is invalidated. The session scoped beans are useful for storing the temporary and user specific data like user ID, application theme, users roles, and application language. Let's go through these attributes one by one. Let's start with user ID. If the user ID is used across multiple HTTP requests, then it is better to store it in the session scope bean rather than querying the database for each HTTP request. If the application supports multiple themes, then user's theme preference can be stored in a session scoped bean to maintain the consistency across all the requests. Once authenticated, the user's roles can be stored in a session scope bean for quick access during subsequent requests. User's language preference can also be stored in a session scope bean to maintain the consistent experience across all the requests. Let's understand the life cycle of a session scoped bean. A session scoped bean is created when a new HTTP session starts, means a user logs in. The session scoped bean is destroyed when the session expires, means the session times out or user logs out or session is invalidated. In a particular session, each user will get their own instance of the session scoped bean. Let's understand the session scoped beans with a use case. We have a request counter web application that tracks the number of HTTP requests made by each authenticated user per session. The application defines a predefined threshold limit. If the requests exceed the predefined threshold limit, then the requests are throttled. Suppose the request counter web application allows a maximum of 10 requests by each authenticated user per session. Then the first 10 requests are processed normally and the subsequent requests 11th and beyond are throttled. The requests are tracked per session, so the request count must be maintained throughout the session. To maintain the request count throughout the session, we use a session scope bean that stores the request count. The session scope bean, a request counter, contains a variable request count that stores the number of processed HTTP requests. The request counter bean is injected into the request counter controller. The request counter bean remains available throughout the session and it is destroyed when the session is invalidated or a user logs out. Let's understand the flow of the application. The user sends a login request to the application. The application validates the credentials of the user. Upon successful validation of the credentials, a new session is created. Then the authenticated user sends a request to the request counter controller. The request counter controller contains one endpoint that increments the request count in the request counter session scoped bean. The endpoint returns a JSON response containing the name of the user and the request count that is made by that user in the specific session. The second scenario involves the throttling of the requests when the predefined threshold limit is reached. As the application allows a maximum of 10 requests by authenticated user per session, so the first 10 requests will be processed and the subsequent requests will be rejected. To enforce the request limit, we can use a filter, a rate limit filter. The request counter bean is injected into rate limit filter and request counter controller. The request counter is a session scoped bean, so the same instance would be injected into the rate limit filter and request counter controller. When a user sends a request to the application, the request is intercepted by rate limit filter. The rate limit filter validates whether the request count has reached to the predefined limit or not. If the request count is below the threshold limit, then the request is forwarded to request counter controller. If the request count exceeds the predefined threshold limit, in that case, the request is throttled. The rate limit filter validates the request count for authenticated users only. I have created a Spring Boot project with Spring Boot version 3.2.4 and Java version 21. I have added three dependencies. The first dependency is for building RESTful APIs. The second dependency is to add Spring security to the application. The second dependency also provides a default login form. The third dependency is for HTTP session management. The project follows a layered Spring Boot architecture with four main packages. The first package is config, that contains a config class that stores the user's information and their rules. The second package is controller, that contains REST API endpoints. The third package is filter, that contains a rate limit filter. The fourth package is model, that contains a session scoped bean. I have uploaded the project to GitHub. The project name is session scope. I will share the project link in the description. In the model package, I have created a request counter class. It's a session scoped bean that stores the number of processed HTTP requests per session. This class is annotated with @component annotation that marks it as a Spring managed bean. This class is also annotated with @scope annotation that defines the lifecycle scope of the bean. By setting the first attribute value equal to scope session, this bean is configured to be a session scoped bean. The second attribute proxy mode ensures that the Spring creates a proxy to inject the session scoped bean into singleton beans. At the runtime, this proxy will fetch the actual instance of request counter bean from the application context per HTTP session. The class contains three members: username, request count, and ID. The username represents the name of the user who has logged in. The second attribute, request count, represents the number of requests which are processed in the session. And the third attribute is ID, which represents the unique identifier for request counter bean. It has no argument constructor that initializes the ID for this bean, and it also initializes the request count by 0. The class has getter and setter methods to store and retrieve user specific data for the session. This class has a method increment count and get. This method is used to increment the request count each time a request is processed. It also has a method get request count. This will return the number of HTTP requests which are processed in this particular session. I have also overridden the toString method to display the request counter bean data in the readable form, and I will also use it for the debugging purposes. I have also created a destroy method, and this method will be invoked when this request counter bean will be destroyed, and this bean will be destroyed when the user logs out or the session is invalidated. In the controller package, I have created a request counter controller class. It's a REST controller that updates the request count in the request counter bean, that is a session scoped bean. This class is annotated with the @REST controller annotation that marks it as a REST controller. If session scoped request counter bean is injected into this class. This class has one endpoint, that is /protected/get request info. Whenever a request is received, then the username is extracted from the authentication object and it is stored in the request counter bean. The increment, count and get method of the request counter bean is invoked to update the request count by 1, and then the updated request count is stored in the count variable. I have added 3 loggers to log the info for debugging purposes. The first logger logs the username and the number of times the user has visited this endpoint. The second logger logs the session ID, and the third logger logs the request counter bean ID. This endpoint returns an object of request info. The request info class contains two variables. The first variable represents the username of the user who has logged in, and the second variable, request count, represents the number of HTTP requests which are sent by this particular user in the session. In the filter package, I have created a rate limit filter class. It's a custom Spring filter that implements a rate limiting logic for authenticated users. It also ensures no user exceeds 10 requests per session. It is annotated with @component annotation that marks it as a Spring managed component. This class extends once per request filter class that ensures that this filter is executed once per HTTP request. A session scoped request counter bean is also injected into this filter. The doFilter internal method first checks whether the user is authenticated. If the user is authenticated, then the rate limiting logic is applied. If the current request exceeds the predefined threshold limit, in that case the request is throttled and a custom error response is created and sent to the user. Send rate limit exceeded response method is used to create the custom error response, and the error response contains status, error message, and the number of requests which are allowed per session. In the rate limit filter class, I have added the loggers to display the request counter bean ID that we will use during the debugging. If the request is throttled, then that information will also be logged. In the config package, I have created a configuration class, security config. This class sets up an in-memory user store, and it also registers a custom filter in the filter chain. This class is annotated with @configuration annotation that marks it as a Spring configuration class. The first method creates an in-memory user store with a single user. The username is JavaLearnerss. The password is Java. The password is stored in the plain text, and the role of the user is user. This method returns an instance of in-memory user details manager class that stores a single user. The user disappears when application restarts, and this is basically used for testing purpose only. This is not recommended in the production. The second method registers the rate limit filter in the filter chain. The method add filter before injects the rate limit filter in the filter chain that is executed after the authentication filters. The endpoints with protected URL prefix require authentication. That means user must be logged in. The other URLs remains accessible. This also configures form-based login authentication. Now I am going to run the application. The application is started and it is running on port 8080. I am going to clear the console logs. Now I am going to invoke the secured REST endpoint. The REST endpoint is secured, so it is asking for login. The username is JavaLearnerss and the password is Java. Now I am going to sign in. Here you can see that the request count is 1 and the name of the user is JavaLearnerss. I am going to send the same request again. Now you can see that the request count is 2. Again I am going to send the request. Here you can see that the request count is 3. Here you can see that the bean ID for request counter bean is same for all the 3 requests, and the session ID is also same. In the request counter controller, the session ID is retrieved from the request object, which is of type HTTP servlet request. I have opened the Chrome browser in incognito mode and I am going to invoke the same REST endpoint. The REST endpoint is secured, so it is asking for the username and password. I have entered the username and password and now I am going to sign in. Here you can see that the request count is 1. The JavaLearnerss user has logged in from the 2 different browsers, so 2 different sessions are created. So that's why the request count here is 1 and in the as browser the request count is 3 for the same user. Now I'm going to check the logs in the IntelliJ. Here you can see that a new object is created for request counter and the bean ID is different from the previous one and the session ID is also different from the previous one. The session ID for the first session is ending with 29DC while the session ID for the second session is ending with 2462. For the first session, the request counter bean ID is ending with 69E2, while for in the second session, the request counter bean ID is ending with 15EA. Now I am going to send the remaining 9 requests. Here you can see that the request count is 10. In the rate limit filter, I have applied the logic that the 11th request must be throttled. So now I am going to send the 11th request. So here you can see that the request is throttled and the JSON response is shown on the screen. The error is too many requests and the error message is maximum request per session exceeded and the error status is 429. That's it for this video. Please don't forget to like, share and subscribe, and please provide your comments in the comment section. Thank you.